Hey guys, this is Mr. Rysz. So we're going to start the next section here, which is the 112 activity, where we're going to design a new app. So we're going to take what we did, the skills and kind of tools that we learned with the first app, and we're going to make another one that uses some more sensors and some more capabilities of our tablet. So today, this is going to be the part one video. Today we are going to do, actually day one video, we're going to do part one and part two here. So let's go ahead and get started with part one. Part one is an activity or assignment that you guys will submit. If you want to watch this video, you can, but let's go over this. So here's the user story. So we're going to create an app that challenges the user to keep a sprite a happy face in the center of the screen. And this is going to be by the time we finish the whole app. All right, so note in this activity, you can make this more challenging by asking the user to balance the tablet on only their foot. So I would not do that because we make those tablets. So the app overview here, the Happy Accelerometer app will help you learn how the program keeps track of where your images are located or placed on a screen. It's important for you to know that as you begin to create and personalize your app, this app will create apps on the user interface to show the location of the sprite and the value reported by the accelerometer. So review the design concepts you need to consider when developing an app. This activity suggests the design component and design and feature activities. You will need to take a user story to create your own design. So let's go ahead and get this started. We're going to make a new project here. So I'm going to go on my MIT App Inventor here and click Start a New Project. My name, I'm going to put JRysz 112, and then I'm going to put part one. Actually, probably put part two as well, because part one we are just going to answer some questions. So here's the design overview by the end of the app. So we're going to have what the user will see here will be a happy face, and they'll have some X and Y coordinates here with the point. This is what we'd see on our designer view, and so on and so forth. So this is not like what we're going to get done today, but this is what we're going to have done by the end of it. So we're going to set up the screen properties so the app matches the default settings for all users. For example, in this app, the user may need to scroll down to see all the features, and you don't want the tablet to change portrait layout. So on screen one here, I gotta move my noggin. In our app inventor here, we're gonna click on the components. All right, so that's over here. What we're going to do here is to make sure that we check the box under scrollable, which is, oh yeah, right here, scrollable. All right. To make a scroll bar appear on the screen if the content is longer than the page. So if we make our screen a little bit too big, somebody can scroll down and only see it. We're going to change the title of the app to Happy Accelerometer. Actually, let's not do that. Let's leave it our name so it sends me the same thing. And we're going to change the screen orientation to portrait, and that is over to the one side. I'm going to try to zoom in so you guys can see better. No, Zoom doesn't record everything. Where is the orientation? I'm probably missing it here. Classic title. Oh, right here. It's underneath the primary color. We're going to click it, set it to portrait, so it at least stays this way the whole time. We can change the background color if you want. I'm going to leave my background color here, just default white. That's good with me. We will change that later on in the app. All right, now based on some user requirements, we're going to develop and add some things here. So we're going to add the accelerometer and an image sprite and a canvas and a label. So an accelerometer is a non-visible component that can detect shaking and measure the acceleration in 3 dimensions. The image sprite is a component of the happy face image that we will use on top of the canvas. The canvas is just a 2-dimensional touch-sensitive rectangular panel that the user can draw on and the sprite can move on. And the label is a component, and we'll need 2 of them to place. So let's start out here. We're going to add the accelerometer. So that is in, and it would tell us in the viewer here. Now, if we can't find it, it's in our sensors, but if you can't find it, you can always just search for it, accelerometer, and click drag that out. It's going to be a non-visible component. We're also going to make sure that's labeled 1. We're going to add a canvas to this. So going to add a canvas onto our screen here. The one thing about this though, we probably want this canvas to take up some of the room. You can see this canvas covers a lot of the screen itself. So let's make the width fill parent. So in the settings for the canvas, width fill parent makes it go all the way across. And we'll set the height to as a percent of 80. So that should get most of the screen there. Now from the drawing and animations, we're going to drag an image. So we'll take this image and we're going to drag it out onto here. All right, so now if we haven't done this already, we're going to get the source files. We're going to get this happy image and this other image here, the icon image. So I'm going to right click and save as. You guys probably can do this, or if you just click on it. So I got happy, and then, yeah, save link as. I think that's the app icon. Don't worry about unzipping it. I already did that for you. The first year I did this, I had them as a zip file, and that became more of a problem. All right, next what we're going to do is drag the image sprite out. Oh, we already did that, but we need to change some of the settings for the image sprite. First thing, we're going to set the picture to, and we got to upload a file. We're going to go to our happy. So I believe that's on my desktop here. Here's the happy image. All right, now we don't want this thing to be too big, so we are going to make the height as in pixels, 50 pixels, and then the width also 50 pixels. There we go. So smaller happy face. We'll rename this image sprite to happy image. So instead of calling this image sprite 1, we're going to call this happy image, and we're going to use no spaces here, and we're using what's called camel case, where every word starts with a capital letter. They're all put together. So this way, when we look at our blocks, we know our coding is for happy image because we're not visually seeing it. So that's why we use the name. All right, next we're going to add labels to the read location reporting accelerometer. So let's go back here. We can look for labels, or in the user interface, it's right there, the labels. We're going to drag them both out here. We're going to change the label's name. One of them is going to be renamed to location label, all one word. And then the other one, rename, is called the accelerometer label. And we'll press OK there. Probably spelled that wrong, but. Okay, so map the width of the canvas. Notice that the boxes are X, Y, and Z. Okay, so if we look here, how wide is this canvas? It should tell us right here what's going on. We'll only use that later on. So one thing you notice too, if we click on this happy image and I move this around, the X and Y locations change. So let's see, the top corner of this is pretty close to like 0, 0. And we can keep going over with the X. So it looks like we can go all the way over to about 259, 260. And then we can go all the way down to about 275. Now Z never changes because that's the depth. So an easy way to keep track of directions, the X, Y, and Z axis, is called the right-hand rule. All right. And so you're going to put your hand like this, just like it's facing the screen. All right. And what works out is that your finger is your X, your up and down is the Y, and your Z is your other fingers pointing towards you. All right, we're going to answer the following question. So you guys will have a text box that you'll have to answer. So we're going to change the X values and see what's the range where the spike can be located. So once again, we just kind of did this here, moving the sprite. How far left can we make this go? The lowest I can get the sprite to probably get to is like 0. I probably can get it more, but it'd be off. And the furthest right we can get to is like 260. Now the Y locations, we'll do the same thing. We'll put it all the way up to the top. The Y, I guess was like -2. I think that's a little off though. Probably 0. And then going down to the bottom, about 275. And the Z has no effect on Y because we are just using 2 dimensions here. A canvas is 2 dimensions, so it's not going to be moving in and out. Okay, so make sure you guys submit those answers and we will work on part 2 next. So let's preview this and take this quiz. So now we're going to look at the blocks view setup. So many of the features and functions of technology are defined by numerical values. In this case, you are tilting the device left or right. The device senses the movement and puts a numerical value to the tilt. All right. To harness these features, it's important to understand the values the device has in the relationship to its movements. You're getting to know the accelerometer a little bit better by learning the values of the tilt. Knowing the tilt values will help you use the accelerometer values in the apps to make events happen based on how the user's holding the app. So we're going to tilt it and we're going to see what numbers are associated with the tilt. Like if we tilt it to the left, what numbers pop up? If we tilt it to the right, what numbers pop up, and so on and so forth. So we're going to go to the blocks view now, and we're going to click on the accelerometer sensor and drag out the accelerometer change, acceleration change. So clicking on the accelerometer label now, we're going to set the accelerometer label text to, so we're going to drag this out and drag it inside here. And we're going to then look at the event handler, and you should see 3 orange blocks, which we do. These represent the variables. So the accelerometer is checking 3 things at all times: the x-axis, the y-axis, and the z-axis. We're going to select the x-axis, so we're going to hover over it and get the get and click it onto here. So remember, to get to the pop-up menu, we just hover over something and get it. Now, if we accidentally get the wrong one, the nice thing about App Inventor is we can click on this and then select the correct one. So, all right, what we're going to do is to test out our app right now and see what happens. So we're going to go ahead and connect and see how this app works. So I'm taking out my tablet here, and I'm going to connect the AI companion, and I'm going to type in my code. It seems to work better when you type in your code. Connect with code, and we'll see. All right, I'm just going to wait for this to load. All right, sorry about that. I had a problem with mine. I had to actually delete the app off of my tablet and then re-download the companion app. So what I'm setting this completely flat, and I'm looking at the bottom. There's some numbers that are hovering between 0.0. Oh, that's nice. Disconnected, but that's still working for me right now. Like 0.04 and so forth. Now, as I tilt it to the right, slowly, I'm holding this flat. So I tilt it to the right. I can see those numbers start going up: negative, -5, -6, -7, -8, -9, and then, okay, I'm going upside down, and it starts going lower. Now, if I tilt the other way, it's positive numbers. So as I move to tilt it to the left, it's positive numbers. To tilt it to the right, it's negative numbers. So question 1 is, what did we see in the accelerometer label? We saw numbers that are moving super fast, and they're very small. Now, do they make sense? Kind of. It made sense that they were constantly changing, because even like the sensors are picking up the slightest variation at all. The one thing that I got confused, like, so if I go tilt it to the left, it's positive. If I tilt it to the right, it's negative. That's kind of opposite of what I would normally think. If I tilt it to the left, I think I would get negative and positive. So we can do the same thing here with the Y, is we can change those to the Y. What I can do here is just change Y and then do reset connection. And now when I tilt it, I can get different numbers with the Y, and we can change this with the Z's. So let's make sure we can match these correct definitions here. My argument is, all right, so let's read this too. The accelerometer showing the data you can use. So these 3 variables, the orange boxes, are like containers that hold values that are changing. The actual numbers or values in these orange boxes are called arguments. The arguments get passed along to be used only by other parts of the program. In this app, these arguments get information of how the accelerometer has changed. The event handler, known with what the current value is from the argument value, and gives appropriate outputs, which makes the happy face move in a certain direction. Using the event handlers to make decisions based on the arguments passed to the event handler is a fundamental idea of coding. So my argument is a value passed to a storage location to be used by the program, and the variable is the storage location. Right. All right, so when it comes to information with the data that we get, there's multiple different types of data that we can have. So we might think about or use this differently, but it's good to make sure we know the correct information. So if we have an integer, that's like a whole number. So if we ever getting whole numbers here, like a counter, if we're trying to click, those are all integer values. A float is like a decimal. So when we're moving on the screen here, we're getting decimals. Those are floats. Now, strings are characters or text that we could type in. So like the word hello or something on the screen that we would see would be a string. And a Boolean is a data type to use true or false. So we use Booleans to help with conditions that we'll talk about later. All right, so let's match these data types. So I have false, that is a Boolean. Peter is a word is a string. 740 is an integer, it's a number without decimals. 2.34 is a float. That is a number with decimals, such as float. 6 is an integer, but 6.0 has decimals, so that's a float. Now, 6 in quotation is technically a word, so that's a string. And definitely the word 6, S-I-X, is a string. So submit that quiz. Let's see, oh, we have one unanswered. Oh, because I didn't. Which one did I not? Oh, this one here. Yeah, I didn't write it up. So if you get a 2 out of 3 on this one, you guys should be fine. Okay, so we really, with this app, haven't done anything here that we need to worry about, need to submit, but we're just building up the blocks right now, making sure we understand everything. So in the next day, we will get everything set up and we'll start doing some more coding. All right, you guys have a great day. See you next time.